Okay, YouTube, in this video we're going to introduce the quadratic formula and kind of talk about what it's good for. But before we do that, let's go ahead and take a look at what it is that we're trying to do. I say up until now we've learned three methods for solving quadratic equations. Okay, so our goal today is going to be to solve a quadratic equation. Quadratic equations, we say, are in general, in standard form, we say ax squared plus bx plus c equals 0. Okay, so when we solved these in the past, things that we've done, we've attempted to factor them and set them equal to 0 and solve by factoring, or we've used square roots. We've even completed the square. What I can say is this: if you were to take a statement ax squared plus bx plus c and particularly set it equal to 0 and then complete the square on this, so do this third solving method, what we'd find out is we actually get a formula that will always give us the x values that would cause this to be equal to 0. And we call this formula the quadratic formula. Okay, so let's say what this quadratic formula is. We say let a, b, and c be some real numbers such that a, by the way, is not equal to 0. Then we say the solutions of the quadratic equation ax squared plus bx plus c equals 0 are these. So essentially what I can tell you is this: if it is a standard form quadratic equation and it's equal to 0, it must be equal to 0, and we can identify a, b, and c, then what I can tell you is what you're going to get for x values. Let's go ahead and write this here. We say these are solutions. We've also referred to them as x-intercepts of our parabolic graph. But we say we would get these x values every time. And another thing we want to note here is that there are two answers. And the way we're determining that we have two answers here is the fact that we have a plus or minus involved here. So let's identify a few things about this formula right off the bat. Starting with, I notice that I get x equals negative b over 2a. Ignoring just this radical part right here, I get negative b over 2a, which I'm familiar with. As a matter of fact, when we've graphed things like this before, we say maybe y equals ax squared plus bx plus c. And then we say the vertex we've acknowledged has been at negative b over 2a, and then the function value at that x value. So this is something that's popped up before. The only new thing is that we have a radical of some b squared minus 4ac. So here's the deal. I just want to go ahead and put this to use and say, let's go solve some quadratic equations. So I make one note here before we begin. It says, before we can apply the quadratic formula, the equation must be written in standard form. So it has to be in this ax squared plus bx plus c form, and it has to be set equal to 0. Otherwise, this won't work. But I say we should use the quadratic formula if and only if we can't factor, nor can we solve using roots. So for something like this, if somebody says, hey, you know, Matt, go solve one of these, we say, oh, what I would get is this. We say 2x squared plus x minus 5 equals 0. So the first thing I want everybody to notice I did was I set it equal to 0. If we're going to be looking for x-intercepts, then I need to set this equal to 0. As a matter of fact, let's go ahead and graph this right now. If I were to graph 2x squared plus x minus 5, let's see what we get. So we say y equals 2x squared minus 2x plus 2x. Was it plus 2x minus 5? And let's just go back and check this here. Plus x minus 5. So pardon me, we'll say plus x minus 5. So already I can tell you that these two things right here, these are the x-intercepts that we're about to go find. And you can see how if I had to do this with factoring, it'd be really ugly. So as a matter of fact, if I tried to solve this a normal way, I'd say, well, can I factor this? Well, I notice that it doesn't factor. That is, if I take 2 times negative 5 and get negative 10, I can't think of two factors of negative 10 that add up to be a positive one in the middle. We could try this by using roots, but see, I have an x squared and an x to the first. So what we're going to have to do is try something different. We could complete the square, which, by the way, I've said, if you were to complete the square in general, you always get this anyways. So in other words, we could just say, if it doesn't factor, and it's quadratic, and it's in standard form and set equal to 0, let's just use the quadratic formula. So the way this works is this. We have to be able to identify a, b, and c. And in this case, we have an a value of 2, a b value of 1, and a c value of negative 5. So we're going to fill this in 2, 1, negative 5. I would always recommend identifying these off on the side. And then the next thing we're going to do is this. We're going to write this all out with blanks. So we say negative blank plus or minus the square root of blank squared minus 4 times blank all over. Now this is 2 times blank. So I've had people before write their letters underneath here. We say this is a B, this is a B, this is an A, this is a C, and this is an A. But we just need to go put the numbers in the right spot. So for instance, we say B and B here are both going to be 1. So I get 1, 1. If I were to plug in A, I get 2, 2. And plug in C, we get negative 5. So now, what I want you to know is this. Right now, these are the answers. These are the solutions. Right now, we're done. We just need to simplify this. So the way this looks is really this. When we simplify expressions in the quadratic formula, we can say that this negative b out front and this 2a in the basement, those are pretty trivial things. They're easy. So I notice that I get negative 1 plus or minus the square root of something all over 2 times 2, which is 4. So I've already cleaned up those parts. It's this inner portion here that kind of worries me a little bit. So we have 1 squared minus 4 times 2 times negative 5. So start with the squared term. We get 1 squared is 1. And I know that a negative times a positive times a negative, or if two of these are negative, I get a positive answer. So this is going to be positive. And I say 4 times 2 is 8 times 5 is 40. So I get this right here. So our two answers actually are these. We say negative 1 plus the square root of 41. It's a 41 all over 4. And we also get negative 1 minus the square root of 41 all over 4. And I want everybody to see this here. So what I'm going to do is I'm actually going to type these into the calculator. I'm going to have to use a little sleight of hand, and you're going to have to bear with me here. But we say in this first instance, we'd say 41. I'll take the square root of that first, and I'll add that to a 1 that's negative. And so on the top, I get negative 1 plus the square root of 41 is this, and I'll divide that by 4. So dividing this by 4, you see that I get approximately 1.35-ish. So we get x is approximately 1.35. And if we were to go back and do this one now, we say, all right, well, square root of 41, which is this number here, we say negative in this case. And if I add that to a 1 that's negative, it just gets even more negative, and divide this by 4. So we get negative 1.85-ish. So we say negative 1.85-ish. Now I want you to remember these numbers right here, because what we just did was we solved this in general using the quadratic formula since it didn't factor. But I got 1.35 and negative 1.85. And when we go look at the graph of this, I get negative 1.85 and 1.35. So what we were actually finding here were actually the x-intercepts, or the solutions to this equation. And all we had to do was set it equal to 0 and use the quadratic formula. So let's go ahead and take a look at this extra example up here. We say, all right, let's try this again. 3x squared plus 8x equals 35. If I said go solve this, I think everybody's first step should be let's set this equal to 0. So moving this 35 back over and getting a 0 here, we say, okay, let's try to factor this first. So if I did try to factor, I get 3 times 35, which is 105. Can I think of two factors of 105 that add up to be 8? And I simply can't, okay, which means this isn't factorable. I can't use roots because I have both a squared term and a to the first power term. So we're going to have to resort to either completing the square or quadratic formula, which, by the way, quadratic formula is completing the square. So let's start with this. We identify that a is 3, b is 8, c is negative 35, and we say, well, then our answers must be these things right here. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Well, we're simply going to put these numbers in this time. So we say b is 8, so I get 8 and 8. A is 3, so I get 3 and 3. And then I get c is negative 35. So in this case, we get, well, then our two answers are negative 8 plus or minus all over 6, this root. So it looks like we get 8 squared is 64. A negative times a positive times a negative, two negatives, that's going to multiply to be a positive. And 4 times 3 is 12, and 12 times 35. So now 12 times 35, I'll bring this up here, we say is 420. So we get 420 in here. So I want to write both of our answers separately, but we say negative 8 plus the square root of, this would be 484 all over 6. And we also get negative 8 minus the square root of 484 all over 6. So now one thing I do want to mention about these are, as a matter of fact, we could get these as decimals, and we should, and go check the graph here, but they're both real, which means we did get a couple of x-intercepts on the x-axis. And furthermore, I also want to point this out. We'll pick on one of these here, but if I got negative 8 plus the square root of 484, I know that this is 4 times 121. I can kind of figure that out on my own. And I know that the square root of 4 is 2. So we could actually rewrite this as negative 8 plus 2 times the square root of 121 all over 6, which, by the way, 121 is a perfect square itself. So we could say 121, the square root of 121 is 11. So we say 11 times 2 out front. We really get this, negative 8 plus 22 over 6. So we really get this. A negative 8 plus a 22 is going to be a 14 over 6. So 14, 6. And then, the same thing over here. We would get negative 8 minus, now the square root of 484, it looks like we got 22 last time, so we get 22. And this is all over 6. So in this case, let's split these up. We say negative 8 minus 22 is negative 30 over 6, and this is negative 5. Okay, so let's go ahead and find these both as decimals really quickly here. I just want to look at these. So we say 14 divided by 6. This x-intercept is 2.33, so this is 2.33 repeating. And then we also got -5 here for our x value. So let's go ahead and graph this. We said, let's see, 3x squared plus 8x minus 35. So 3x squared, we have plus 8x, so we say plus 8x minus 35. This is our parabola right here. So I can zoom out so that you can see that we have a parabola here that opens up. But really what I want us to see is we found two x-intercepts, and one of them was -5, and the other one was simply 2.33, which were supported by the quadratic formula. So this thing right here, just because I said I couldn't think of two factors of 105 that add up to be 8 in the middle, just because I couldn't think of them off the top of my head doesn't mean that this thing wasn't factorable. As a matter of fact, this is factorable. And we can see that because we got some nice, pretty rational numbers down here. But that's how you use the quadratic formula to pick apart a quadratic thing when you want to find the x-intercepts of the solutions. Cheers.